So, I don't know about you guys, but I'm kind of like in this place where I think it's because the cold weather hit, right? I'm dreaming of Hawaii right now. Would anybody else like to go like to Hawaii right this second? Like I could easily pack a plane, replace all my wardrobe all there, and just like hang out in Hawaii. That'd be sweet, right? Yeah. So, if I went to Hawaii, you know what the first thing I would do is? I would talk to my buddy Pete, who has this like thing where he takes you out on a Jeep tour. And because he's got this cool 4x4 Jeep, he can like go off-roading and stuff like that. And it turns out my buddy Pete in Hawaii, he has this Jeep that'll hold up to 6 people, and that's what he does for a living. He drives around Hawaii and lets people like see like some of these more rugged terrain places. Cool. And so Pete, he only runs his tours when it's going to be profitable, right? So he won't run the tours unless he has at least 2 people. Is this okay? All right. Sometimes he gets 2 people, sometimes 3 people, sometimes 4, 5, 6. Okay? So this probability distribution is the amount of people that are going to go on one of Pete's Jeep tours. Cool? So you can see most frequently he gets 4 people, sometimes as many as 6, though it's pretty rare to get 6. Cool? All right, so we're going to call this variable x. And so this would be p of x. And all I want to know, guys, is what is the mean and standard deviation of x? How would we find those? Go ahead and put the number of passengers in L1, their probabilities in L2. Thank you. Guys, what are we getting? Yeah. Stat, arrow over to calc. One variable stats. And you're going to want your list to be L1, and then you got to change that frequency list to L2. You get to the L2 by hitting second 2. I'm sorry? Are we supposed to say the variables? The values you're getting? Yeah, so did you get 3.75 for the mean and 1.09 for the standard deviation? Okay, from there, you guys, I want to make sure we understand what work would be expected to get full credit if this were, say, a free response question. Okay, you would have to do 2 times 0.15 for the mean anyway. And then this is like one of those cases where I would definitely start considering doing a ... also known as an ellipsis. If you guys didn't know the name of that punctuation mark. Did you guys know that was called an ellipsis? We good? All right. And then for our standard deviation, that work would look like a giant square root symbol. Yeah. And for each one, we would do the possible outcome minus the mean. So the 2 minus the 3.75 squared. And then the probability of that 2 was 0.15. And then we'll do something similar. And then ... to do the last one. So as long as you have the first 2 showing that you know it's not just the first one, the last one, that it's everyone. And then the very last one where you would stop adding them. That's perfect. All right. And do those values seem about right? They feel pretty good? Yeah, I'm pretty comfortable with those. All right, now, Pete doesn't just do this for free. So for each person that goes on his trip, he charges $150. Everybody with me? So the total money he'll collect, if he has 2 people, would be $300. If he has 3 people, it'd be $450, right? And so what we really have is this kind of new distribution where the money he collects is equal to 150 times the number of passengers he has. So one way we could find the new mean and the standard deviation is we could just go ahead and fill those in, change our values in L1 to the 300, 450, 600, 750, and 900. So go ahead and do that for me real quick. Everybody good? And let's see, for our new mean, what did you guys get? 562.5, which, since this is money, we'll write it as $562.50. Okay. And let's see, that standard deviation, 163.46. You should double check me because I'm trying to do these from memory at this point.
I'm sorry, but could you say again how?
Stat, arrow over to calc, option 4,
Okay.
and then that frequency, did I say 4?
Yeah.
I didn't mean that at all.
Okay. I'll go back.
At all.
Okay.
Stat, arrow over to calc, option 1.
Okay.
Okay, it's asking you which list, that's going to be L1.
Mm-hmm.
Your frequency list is L2, and then just hit enter.
Oh, okay. For some reason, it's okay.
I just got pre-sale, so it's exciting news.
Oh, for Taylor Swift?
Uh-huh.
That is pretty exciting news.
Yeah.
I mean,
For Detroit,
I don't know which one I'm gonna choose.
this is really exciting. I'm really excited.
is there a limit to how many you can buy?
6.
6.
Got it. I see.
Will you be pulling up?
To Taylor Swift?
Will you be attending the concert?
I will not. No. I think my sisters and I might see Pink this summer,
That's
though.
exciting.
Pink is coming to Detroit.
When? Like,
In the summer. In August. I think so. I think we might go. But she's going to be in Cincinnati earlier, but my sister lives near Detroit. So we'll go to the Detroit concert. Okay. Hey, guys. Are you guys with me? That I could have just taken that 3.75 and times it by 150? And that's what I said. Times it.
Okay. I can get behind that. That's more fun.
Oh, you're on my list now. Wow. Okay, so here's the deal. If you don't want to type this all into your calculator again, right? If we don't want to run those one variable stats each time. Since this entire probability distribution is just 150 times the previous one, we can multiply the previous distribution's mean and standard deviation by 150. And we're going to get the exact same answers as if we retype it all in and do the one variable stats. Okay? So, now, I want to make some sense of standard deviation because it's about to get messier and messier, right? Standard deviation is where things get really complicated. Okay. What does standard deviation actually measure? The average distance from the mean. Another way of thinking of that is how spread out the stuff is. Yeah? How much variability we have. And are you guys with me that the distances in this distribution are bigger than the distances in the previous one? In other words, 300 and 900 are further apart than 2 and 6. Does that make sense? Okay, so when we multiplied, the distribution got more spread out. Now, it did so consistently, and that's why our mean and standard deviation both got multiplied by 150. Is this okay? So next. So Pete collected 300, 450, 600, 750, and 900. But it's not like he can run those tours for free. It costs him money too, right? Like gas, maintenance on the Jeep or something like that, okay? So let's go ahead and say it costs him $100 every time he runs the tour. What's going to happen to each of these numbers? This is how much he collects, but it costs him 100. They're all going to go down by 100, yeah? So we're going to this is how much money he's collecting. After he pays the $100 for his gas, he's only keeping $200. Cool? All right. One more distribution. This distribution is going to be Pete's profit. We're going to call it V. And so if he collects 300, but it costs him 100, we're going to take 100 away. Now he's only making 200. What if he collects 450? What's his profit going to be? 350. And then so on and so forth. Each of those values go down by $100. Will the probabilities change? Nah. So this will be 0.15, 0.25, 0.35, 0.2, 0.1. Yeah. Yeah.
So like where is like 200 from? Where is it?
You're saying, well, he collected $300. If he had 2 passengers, he collects $300, but it costs him, he has to pay like $100 for gas. Think of it that way. So his profit is not just going to be the money he collects. So I took the 300 and took $100 away from it. Now, I want you guys to envision what would happen here. Here's my group. Here's my graph of all these things being all this collected money, and then I take $100 away. What's going to happen to the graph?
It's just gonna shift down.
Well, left, but
Right.
the whole graph is going to shift left. Is everybody with me? How much is it going to shift? 100, right? Is it going to get more spread out?
No.
So is the standard deviation going to change? No. And when I look at this, the distance between that 200 and 800 is the same as the distance between 300 and 900. Okay? So as we go to do these, the mean and the standard deviation, the standard deviation is going to stay exactly the same, 163.46. Because what's going to happen? The whole graph shifts left. It's not going to get more spread out. It's not going to get less spread out because that all shifts together. The mean the mean's going to go down to 460, was it 462.50? Yeah. Yeah,
So why'd you change 0.05 to 0.1?
I didn't. This is 0.05, duh. I was doing it from memory, not from looking.
Okay.
All right, big idea. And this should sound familiar. We talked about this in Unit 1. If what I'm doing to my distribution, whether it's a probability distribution or an actual real life distribution, okay? If what I'm doing is adding or subtracting, the mean will change. The standard deviation won't. If what I'm doing is multiplying or dividing, both the mean and standard deviation will change. How are we feeling, okay? All right. Now, let's go ahead and say I'm buying a new bathtub. And in particular, if I have a new bathtub, I want to make sure that the water doesn't get too hot or too cold. Okay? So, I've happened to get this place from Canada. And so this tub from Canada. And so they described the mean in Celsius. You guys, I'm not that good at Celsius. Is anybody in here good at Celsius? It's a little bit weird because we're raised on Fahrenheit, right? And so we're so used to Fahrenheit. But in Canada, I think they use metric, yeah, in Celsius. Is 34 degrees hot, cold?
It's warm, but it's not like it won't hurt you.
I grew up in it's hot.
That's hot?
Yeah.
How hot is it?
It's like 80 or 90.
It's more than that, yeah. But if this is your bath water, you guys, you would want your bath water to be pretty warm, right? Like if your bath water was 98.6, it would feel like the same temperature as your skin. You guys get what I'm saying? So bath water being 80 degrees,
That's pretty cold. Yeah.
it would be kind of cold. I mean, unless you like,
Average pool is in like the 60s or 70s, so
yeah. Yeah. So, instead of trying to think this through in Celsius, for which I feel like I don't have a good grasp, I'm going to think through what would all these temperatures look like if I converted them all to Fahrenheit. Is everybody with me? So if I converted them all to Fahrenheit, the way I do that is I multiply the Celsius temperatures by 9/5 and then I add 32. Okay? So let's kind of go through and say, we're going to talk about these kind of together. So when I multiply all of those temperatures by 9/5, will the mean change?
Yes.
When I multiply?
no, yes.
When I multiply, the mean will change. I get 9/5 times 34. Will the standard deviation change when I multiply?
Yes.
Yeah. So I'm going to do 9/5 times 2. Then, after I multiply by the 9/5, I'm going to add 32. Will the mean change when I add 32? Yes. Will the standard deviation change when I add 32? No. So if I want to know the mean of the Fahrenheit temperatures, I do 9/5 times 34 plus 32. I'm sure that has a number. I think it's like 93.2 degrees Fahrenheit. And then the standard deviation will be 3.6 degrees Fahrenheit. right, so now this is describing this probability distribution of temperature. Hey, is this discrete or continuous? Continuous. So we're going to do like an area thing. And since I told you it was normal, that was lovely. Now, yeah. Because what's going to happen if I add 32? The whole graph shifts. It doesn't get more spread out. Oh, it would shift this way for adding. No, the standard deviation does not change when what we're doing is adding or subtracting. Then we find the area in between 90 and 100. Because in this case, we're describing, say, a baby to be in between 90 and 100 degrees. And I think 78%. Does that sound about right? Yep.
Okay, this is really different about the previous problem, but for the standard deviation, why do you multiply by 2? Oh, never mind, this is going to be division, sorry.
So yeah, I multiplied the 2 by 9/5, not the other way around.
Okay, yeah.
We feeling okay? All right, now, from here, the goal is to kind of lay some groundwork for tomorrow so that we might start to see and notice some things. Okay, so we're going to introduce Miss Meister doing a new game where she makes some spinners. Okay, and then, in fact, I used a website to create this spinner just for you guys. There are 20 spaces on this spinner. We're going to call, by the way, we're calling this spinner Spinner A. And the game is going to go like this. You guys are going to get to spin spinner A. You get a certain amount of points. And then you spin spinner B. You get a certain amount of points. And when you add together your 2 amounts of points. So what we want to start looking for is what happens when I add spinner A to spinner B. What happens to that distribution? Is this okay? All right. So before we can talk about that distribution of the total amount of points, let's look at distributions A and B separately. So on spinner A, we have 3 outcomes. What are those 3 outcomes? 0, 7, and 16. And there are 20 total spaces on the spinner, okay? So as we go through and we count, I'm going to count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 20 zeros, which, by the way, works out to be 0.45. And if I count, out of laziness, I'm going to count the 16s next. I have 2 16s, which makes 0.1. And I just didn't want to count all the way around, which leaves another 45% to be having 7 points. So the probability you get no points at all on this spinner is 45%. The probability you get 7 points is 45%. The probability you get 16 points is 10%. Is everybody good? All right, so all I need to know for right now are what are the mean and standard deviation for spinner A. I think, what are we getting? 5, pretty much. 4.75 and 5. Okay, good. Let's do spinner B. These options look to be 0, 8, and 40. Only 2 zeros, am I right? So that's 0.1. And 3 40s, so that's 0.15, leaving this to be 0.75. Guys, you guys are putting these in, yeah? What are we getting for our mean standard deviation this time? 12 and 12. Weird. All right, now, this next piece is we're going to create a new distribution that is adding together these two. So as we think this through, we should think through the all the possible outcomes. So that first spinner, you could either spin a 0, a 7, or a 16. And those probabilities I'm just going to kind of write in are 0.45, 0.45, and 0.45. No, that's not true. You guys, this is a 0.1. All right. After I did that, I spin the second spinner. And that is either 0, 8, or 40, yeah? And those were 0.1, 0.75, and 0.15. Is that correct? Okay. All right. So here's what I want us to do next, y'all. I'm going to make a new distribution called T. And guys, all T stands for is the total. How many possible outcomes are there for T? 9. So, if I'm here, that would mean I got 0 on the first spinner, 0 on the second spinner. Is everybody with me? How many points do I have? 0. And can we find the probability of getting that 0? Yeah. We would just do 0.1 times 0.45. Guys, I can do that one on my own. That one's 0.045. If I do the next branch down, what would that mean? 0 on the first spinner, 8 on the second spinner would be a total of 8. That one I can't do on my own. Can somebody help me out? What is 0.45 times 0.75? 0.3375. Cool. All right. And then if I do 0 and 40, I would get 40 points. And I don't know that one either. 0.675. Perfect. All right. Next branch down, what's my total? 7. I know all of these probabilities, y'all, because they're the same. Next branch down, my total is 15. That will also be 0.3375. Okay, and then 7 and 40 is 47. So that'll be 0.0675. Is anybody else starting to get really irritated with this?
Yes.
Me too. This is the 4th time I've done this problem today. Super irritating by now. Hey, what are my last possible sums? 16, 24, and 56. And the probability of 16 should be 0.01, then 0.075, and 0.045. All right. Is this every possible outcome?
Mm-hmm.
Every possible sum?
Wait, shouldn't that last probability be 0.015? Because
Yeah.
times 1.
Yeah, I wrote the wrong thing here. You are correct. So this is supposed to be 0.15, which changes this probability to 0.015. All right. Now, our goal in doing this is to start to get some ideas of what happens when we add together 2 different variables. And so if I asked you guys to find the mean and the standard deviation of this new distribution, first of all, this is an annoying process, isn't it? So that gives us kind of some incentive to make sure we master the process that I'm going to show you guys tomorrow. Because you don't want to be doing something like this. Ellie, did you find the mean and the standard deviation? What'd you get?
The mean is 16.75 and the standard deviation is 13.
The mean is 16.75. The standard deviation is 13. Tomorrow, we're going to learn some shortcuts to get there. The rest of today, you can either work on test corrections or whatever. When are raw scores going in? Friday.